Hello, today we're going to be dealing with the binomial theorem. Now, as you may have guessed, the binomial theorem deals with binomials, specifically when they're raised to a certain power. Before we get started, I want to clarify a few formulas for us that will be pertinent in our discussion. The first one, n choose r equals n factorial over r factorial times quantity n minus r factorial. So, you've got to keep that in mind throughout the discussion. And the key, what you want to achieve when you use the binomial theorem is to expand a binomial. You have to expand it. So our first example is going to be quantity x plus y squared. Now a lot of you probably already know what the x squared plus 2xy plus y squared, but it's a good chance for me to apply the binomial theorem in a fairly simple case. So first we start with using this formula. Now, we see that the exponent here is 2. So we can put a 2 here. Choose. And this is the first term of the expansion. So we're going to put a 0. Seems kind of counterintuitive because 0 is the first term, and then 1 will be the second term, 2 is the third term, etc., etc. And then you take that first term to the exponent, like that, x squared. Then add 2, choose, this is the second term, 1, times, here you might not have seen it, but it's y to the 0. There it's y to the 0. So we're going to take away an exponent from x and add 1 to 0. So we're going to take away 1 from 2 and add 1 to 0. So x to the first, which is just x, so we can just erase that. And then y to the first, or that's just y2. We don't need, it's redundant to put that 1 there. And then finally, to choose 2, we take away another 1 from x, we add another 1 to y. So now we get x to the 0, which is just 1. It's redundant to put it there. And we get y to the second, because y to the first plus another 1 is y to the 2. Okay, and then we can simplify. Whenever you have a number and then you have choose 0, it's always 1. So it's 1 times x squared, which is x squared. 2 choose 1. I mean, you can plug it into the formula. 2 factorial over 1 factorial times 2 minus 1 factorial, which is 2 factorial over 1 factorial, which is just 2. So x squared plus 2, and then we have our xy there, 2xy. And this, whenever you have it, the first and last are the same. It's always 1. So it's just 1 times y squared, which fits, if you FOIL it out, you get the same thing too. But I use the binomial theorem in this case. So we can try another one. Erase the board. Erasing the board. Erasing the board. Okay, here we go. So now we're going to try quantity x plus y cubed to the third power. And now we're going to use the binomial theorem to expand quantity x plus y to the third power. So the first, you see I said 3, so 3 choose, so this is the first term 0. And then you take the first term and you put it to the exponent, so x cubed. And to make it easier this time, I'll put y to the 0. the second one. Get 3, choose 1. Subtract 1 from the exponent of x, add 1 to y. So x squared y plus 3, choose 2. I'm going to have to go in the next row on this one. You take away yet another one from x, so you just get x to the first, which is x. So x, y to the first plus 1 is y squared. And then finally, 3, choose 3. You always stop when it's the same number. And then we take away yet another one from x, so that's x to the 0, which is just 1, and then y to the third. And to simplify it, 3, choose 0. Again, whenever it's 0, it's going to be 1. Whenever r is 0, it's 1. So 1 times x cubed times 1. So 1 times x cubed times 1 is just x cubed. The second one, 3, choose 1 is 3. If you plug it into the formula, you get 3 factorial over 1 factorial times 3 minus 1 factorial, or 1 factorial is 1, so just, disregard that for now. Over 2 factorial, which is 6 over 2, which is 3. I'm going to put 3. So plus 3 is the first coefficient. And then you have that x squared y there. And then this next one, if you plug it in, you get 3 again. I'm not going to waste your time with that one again. So 3xy squared. And then again, it's the same one, it's 1. So 1 times 1. So 1 times 1 times y cubed is just y cubed. So that's the expansion of that. And finally, I'm going to do one more, and I want you to try it. So if you want to try it, pause the video, because right after I write it down, I'm going to give you the whole shebang, as a whole deal. Okay, so this formula. Whoops, should have kept that boundary there. Okay, and then so now we're going to try x plus y to the 4th. Okay, so pause the video now if you want to try it on your own, because I'm about to do the answer in 5, 4, 3, 2, 1. It's answer time. Okay, equals 4's in again. 4, choose 0 because it's the first one, times your x to the 4th, first one to the 4th, and y to the 0, which is just 1, plus 4, choose 1, take away 1 from 4 and add 1 to 0, so we get x cubed times y to the first, which is just y, plus 4, choose 2, which is you subtract another one from another one from that exponent and add another one to that exponent, so you get x squared, and then you get y squared, plus the next one, which is 4, choose 3, subtract another one from the exponent of x, add another one to the exponent of y, so you get x, y cubed. And then finally, 4, choose 4, take one more away from that, so you get x to the 0, which is 1, and then y to the 4th. And hopefully by now you've noticed that the exponents of all these terms always add up to 4, which is this one. 4, 0, 3, 1, 2, 2, another 0, 4. And then you just got to do the dirty work for this one. If you memorize Pascal's triangle, you'll know it. But so you just got x to the 4th plus, this one is going to be 4 factorial is 24 over 6, which is 4. So 4 x cubed y plus, the next one is 6. So 6x squared, y squared. And this one's 4 again. 4xy cubed. And then finally, have your 1 at the end, because those are the same. And just y fourth. Okay? So that's your final answer. Okay. Thanks for watching. I hope I made it a little bit clearer for you if you were confused. Sorry if I didn't, that I wasted, how long? 10 minutes and 48 seconds about of your life. Okay. But thanks for watching anyway. I appreciate it. Bye. Subscribe. That's right. Subscribe.